Hey adapters, welcome back. Today our guest is Erin Rothman. Erin has 18 years of stormwater and remediation consulting experience working with cities across the United States. Recognizing a need for innovative data capture to manage urban and coastal flooding, Erin founded Storm Sensor with the objective of managing climate risk through creating intelligent stormwater, sewer, and coastal infrastructure. Today we'll be talking about Storm Sensor's Terrapin software. The Terrapin network is a turnkey solution that monitors flow and flood risk in real time. Storm Sensor's algorithms generate valuable insights into your sewer and stormwater systems, empowering you to take action. Hey, Erin, welcome back to the show.
Hi, Dad. Thank you for having me.
All right, we had chatted before, but I do want you to give us a little bit of background. What is Storm Sensor?
Lovely. So Storm Sensor, we work with cities across the country to deploy data networks. We start with our scoops, which capture temperature and flow in real time. We pull that data into our Terrapin software, which we'll be talking about today. And that gives cities access to basically a system diagnostics within storm, sewer, and coastal systems that happens beneath the streets that you wouldn't see otherwise. And it helps them really understand what they need to do for maintenance on a short-term basis, but then also implement effective capital improvement fixes.
Okay, so let's dig into Terrapin, the software itself, just, broad, and then maybe we could dig down into some of the details. What is it?
So what it does is present accurate temperature, flow, and precipitation data for every monitoring point every 5 minutes every day. And that allows our customers, like I said, to understand exactly how their systems are functioning. We provide a series of summary analytics that include like average base flow conditions, percent capacity available within the pipe or within the vault, so they understand if a flood is or if a storm is coming, what issues might arise. We also provide a series of notifications and maps that let you know where you have a flood risk. We call that critical depth. You can set that critical depth level, and we usually set it obviously inside that pipe below the ground. And what that allows us or our customers to know is when they hit that level, we're about to see surcharging or flooding above ground. And we also have combined sewer overflow notifications and quantification, dry weather flow, stormwater flow, a series of different alerts that our customers use to manage their systems. And of course, you can download the data. We do run real-time QA/QC on every data point that we capture with our sensors. And then we also combine all of that with weather data, and that includes everything from precipitation to temperature, wind direction, wind speed. And you can do additional analyses on that yourself if you like.
Okay, so what you just described, it sounds like a lot of information. So even like a city person who's you're working with there, that's a lot of data that they have to interpret. I mean, is it easy to interpret? How do you, I mean, it's a lot of it's just the interface. How do you guys do that?
Absolutely. We had one customer who said that they want to swim in solutions, not drown in data, which is just adorable. So we've worked very hard to not just present a bunch of data that someone else has to interpret. Of course, you can, like I said, you can download it and run your own analyses if all you want is the data. But we provide a series of insights associated with that data. So one example is that, I mentioned we measure velocity, and when you're talking to a customer, when you're working in stormwater, initially you want the velocity, but you don't actually care about the velocity in the pipe. What you care about is whether you have a backup, whether you have a flooding issue, whether you have sufficient capacity within your system to handle a storm event. And the individual data points that we collect, which is velocity, depth, and temperature, all of those combined, if analyzed properly, gives you that ultimate why it is that you want the data and what you want to do with it and how can you optimize your system. So that's where the summary analytics come in. And then we're also, as I mentioned to you before we started, building out our Terrapin AI platform, which in addition to time series data, we also present that on a map so you can understand where within your system you have those issues, looking at historical trends, and then also upcoming events and predictive alerts.
Okay, so this is pretty sophisticated data that they're going to now have access to. It must be a bit of a transition that if more traditionally, if there's historic information, but they don't get this kind of in-depth real-time data, how does that process work? That you must have a general sense of like, okay, we know what maybe generally what the storm and weather is like in your particular area, but then you're going to get a lot more information. How do they kind of deal with that transition?
So what we do, a lot of times our customers will have a specific rain gauge that they want to use or a series of rain gauges, or they have different locations that they measure that might be different than what we're looking at. So we will also prepare customized reports for them at no additional cost, just to incorporate all of that information and summarize it, map it, and help them understand exactly what's happening, like really integrate all of those disparate data sources.
Okay, so how do they use that though? You're there to help them interpret though. What would you see? And maybe you've already worked with cities. What kind of decisions are they making based on this information that they now have?
There are a couple of different, well, actually many different things. So if you're looking short term, there are cities whose public works department review all of their monitoring points every morning, and then they direct their crews to address any maintenance issues based on the data that they're seeing. Perhaps a siphon is clogged or a tide gate is stuck open, so they can manage it that way. We also work with cities. Again, I mentioned the critical depth alerts for flooding. So they'll receive those alerts and then go out and close street intersections that they know are about to flood so they can protect human life. And that's on the short term. We also do, or they would use it for things like complying with EPA regulations related to combined sewer overflows. So receiving those notifications when an overflow has occurred, being able to notify their community when that's happening. Quantifying the volumes and the frequency and the volume of the combined sewer overflows for reporting purposes. And then also that becomes really important when they have to separate their combined systems and their storm systems. And these are for the older communities. There are 850 in the country that still have these combined systems. So separating that, knowing the volume of water that has to be pulled out and moved into the storm system, and actually having accurate numbers for that becomes critically important, which leads to the long-term implications of the data that we generate, which is really helping us understand where within a system the issues are, why those issues are occurring, and how much water needs to be moved or managed to address those issues. And that leads to the longer-term capital improvement projects.
Wow, I mean that's pretty great that you ultimately your data could be there to reinforce this need to make, I guess, big infrastructure investments, and it's just, I guess, giving a lot of the city folks, well, look at this, we've got this real time data. That must be very satisfying when you find out about these things.
It is. Sometimes they get really mad because that's not how their system works. So our data are wrong. And then we go and someone goes out to prove it. And it turns out that things aren't working as expected.
Okay, right. They maybe it's too much information, but I'm sure too that that information is also hopefully that depending on how the cities run, that they can integrate that with public health. That idea that we know that this area, these corners are going to flood a bit more. Now we have real time information. That too is probably getting cities to kind of think about it differently to what stormwater really means.
Oh, absolutely. And it's been interesting too when we started this, and I started selling to customers to cities, and I would talk about stormwater. They're like, "Oh my gosh, we're fine. We are compliant with our stormwater regulations." And I'm like, "Great. Well, what about urban flooding?" And they're like, "Oh my gosh, we have huge urban flooding issues." It's the same thing, just different terminology. So understanding that the stormwater, if improperly managed or it can't be properly managed, becomes those flood risks, is critically important.
All right, you talked about this a bit earlier, but I want you to elaborate that you have these different products, hardware, software. How does the Terrapin really integrate with all the different systems that you're using?
So we have our scoot sensors, and like I said, those monitor temperature, flow within a pipe or a vault every 5 minutes. Those sensors pull that data to the cloud, and then that data is entered, or I guess pulled into your Terrapin platform. So you can see data coming in as we're capturing it. What we also do is we have a SURFR index, which is a stormwater urban flood risk index, and we'll use that to basically quantify relative flood risk within a community. And that incorporates not just elevation and distance to surface water, but also a number of socioeconomic parameters related to income and population density. And then using that SURFR index, you can identify where within the city your highest risk areas are. Then we'll work with cities to focus on the initial deployment of their scoot sensors and their data network within those high-risk locations, so we can capture the data that they need and make the biggest impact quickly in the areas that need it most. And then ultimately combining that to be Terrapin AI, where we have those spatial insights available to you as well.
All right, so you got my brain thinking like the value of this data too, and you're monitoring temperature. You're a relatively new company though, but over the long term, if you think of cities are going to get hotter with climate change, are you even seeing any little bit of trends associated with like, all right, well, this impervious surface is just getting super hot, and we can just show you how those temperatures are rising?
Oh, absolutely. It is fascinating, sad, fascinating. But one of the reasons that we added temperature was to look at the impact of green space or green infrastructure on stormwater flow, because in many locations, high temperature water, so that hot water flowing into cold water streams, is a pollutant and can devastate an aquatic system. So if you understand where those trends, those hotspots are within your city and then within your stormwater, you can address that and improve the aquatic environments. But then you're also able to confirm, oddly using stormwater data, where those heat island impacts are most significant in your community.
Well, it's people are getting more comfortable, but the idea of thermal pollution, it's a term that doesn't get used enough. But you're
Right.
there giving that the data, and I imagine people over there in the forestry part of the city, government want to use your data to say, look, let's plant some more trees, let's get more green space,
Mhm.
and that's going to help with these things. And so,
Exactly. Exactly.
are you hearing any of those kind of conversations though?
We're starting to. I guess the first few years, people thought we were crazy, and now we're starting to get people excited about that temperature data. Because initially it was for cities to identify different sources of like illicit discharges or inflow of sanitary into a storm system. But now that we're starting to publish the data that we have and showing how that those impervious surfaces directly impact temperature, it's becoming a much more exciting opportunity.
Well, that is very exciting. So this has been a very active year for weather events, and I probably could say that every year going forward. I just anticipate that's what's going to be the case. So how has that tested your product? You are in different communities, and I think on the East Coast, do you have any examples of like, all right, well, we were there monitoring what was happening during these events?
Yeah, it was interesting. So we have, critical depth set up and we're in Jersey City. Um, we could track all across the city where we had these sensors exactly where that urban flooding was happening, which was pretty consistent. So, I mean, I want to be clear, when you have several feet of flooding, we can't necessarily fix that. But what we can do is provide the data to understand where your highest risk locations are, even in a best case situation, and then extrapolate that out to what happens in worst case situations using real data. So it's tough to watch, but it's exciting to know that we're actually capturing data that we can use to solve some of these problems.
All right, a lot of the things that you covered, it touches upon this, but really the cost benefit of using your product. What does a city planner really get? I guess that's part of your conversations with them. How can they justify it?
A lot of it has to do, at least in the short term, with streamlining maintenance. So one example is we are starting work with a city in the Northeast, and they have a combined sewer overflow or a combined system. So they have to report to the EPA every time they have a combined sewer overflow or a CSO. To do that, they have 50 outfalls that are under manhole covers in the street. And every week and every time it rains, they go to each manhole, they open it up. There is a foam brick tied with a rope to the top of the manhole. They look down, and if the brick is on one side, it's good. If the brick is on the other side, it's bad. They make a note in their clipboard. They move the brick back, they close the manhole, and they go to the next one every week and every time it rains. Our system automates that entire process. And when we're dealing with budget shortfalls and labor shortages, that becomes critically important, because then they can actually work on significant projects and not have to do that basic manual labor that's um, easily replicated.
All right, so who can, if you go into you're doing I guess a deal with a city or something that's going to use your product, who can
Mhm.
access that information though? How does that work? Can people,
So we provide anyone in the city can, or who, I mean, we can provide anyone within the city access, and they can assign access to the system as well. If they want to use our alerts or notifications for other systems, for example, for public notice of combined sewer overflows, we provide an API and we'll work with their tech departments to call our data into their alert system. So we make it pretty easy and we don't charge per seat, because another thing that's been really interesting with our data is that the Public Works Department uses it for maintenance, sustainability and resiliency use it for flooding, planning uses it for capital improvements. And we want to make sure that everyone has access to that data and it's easy to use for each one of them.
So I'm curious, has any researchers, maybe even at universities, they've gotten wind of what you've got here? Or have they showed any interest? Or, I mean, do they need to be clients? But it's just like, wow, that's just some amazing data as they sort of kind of think because there's a lot of interesting research going on around stormwater.
Absolutely. Yeah, we have talked to a few different universities about projects that they're looking at. We're still working on the understanding that because we're selling a platform, what we're replacing is a sensor industry or a software industry. And so many people are still so used to just getting the sensors, because then they can get the data. And if they pull the data, then they can do the analyses. And if they do the analyses, then they can get the insights. And there's this whole stepwise process. And there are a lot of people, and a lot of them in the research institutions still are really focused on, well, you guys sell sensors, so can we have some sensors? And of course you can. It's just not going to get you necessarily what you're ultimately looking for.
You'd mentioned earlier that a lot of cities have this combined sewer and just stormwater system. Is there a transition to try to separate those two? And does your data help make that? I mean, you sort of said it helps make that cause, but I mean, I lived in Atlanta, had some serious issues with that too. And there was always this struggle. Do we make this investment? It just seems like if there was more data that sort of, this is what we're monitoring when actually we're getting this combined flow, it's not a good thing.
Absolutely. So like I said, we can monitor obviously the volume of combined sewer overflows. And what we are also doing with cities that are separating their systems, which is mandated by the EPA, is that we're monitoring as they build separate storm systems, we'll monitor the volume of water, of stormwater runoff, in addition to the combined sewage overflows, to document how much water is being pulled out of that combined system and being pulled out of the treatment plant to give more space to that sanitary sewage going into the plant. And so that's kind of cool because we can monitor the actual progress as they start to separate that system. And then also monitoring the actual volumes, because what happens is that without monitoring, especially over the long term and especially seasonally, is that you are using a model that is based on a series of estimates, and models are excellent tools, but they're models, so they're not correct. So what you end up doing is building a replacement system based on a model that might be validated, but it's validated over the short term. And there are cities all along the East Coast that have done that, built their separate storm system, still have massive combined sewer overflows because they didn't have accurate quantification of those overflows. So they didn't know how much water really had to be managed.
I always just was shocked when you hear about those overflows. It's like, well, what happens to it? Well, see that local creek? And it's like, that's what happens with for a lot of those communities. Like, wait, we have no place to put that water, so we're going to stick it out. And that was just so depressing to think that it's pulsing into these natural river systems. So
yeah, well, what's happening is that the systems were designed to treat both sanitary sewage and stormwater runoff, but they're designed 50 or 80 years ago. And we have more people and we have more pavement and we have less infiltration. So that stormwater runoff combined with additional sanitary sewage from growing populations means that instead of all of it going to the treatment plants are getting overloaded. They have to close those gates so they don't blow the plant. And then that sewage discharges into our waterways. And that's where you get the shellfish warnings. And that's where you get the notifications that you can get sick or rashes or a variety of diseases if you touch the water, let alone the ecosystems directly affected by those.
Okay, so let's talk about the future. There's always seems to be products that you guys are working on. Let's talk a little bit, maybe get a sneak preview of Surfer. What's Surfer?
Mm-hmm. So Surfer is the Stormwater Urban Flood Risk Index. And what we learned as we're working through looking at different flood risks was that FEMA in many cases didn't necessarily accurately represent flood risk There's a lot of politics involved, a lot of insurance funding involved. And what we also started to notice was that a lot of the flooding that we were encountering with our systems was in older areas of the community, or older areas of the city, and oftentimes in lower income communities. So what we learned then was that if we looked at both, the physical parameters like elevation, proximity to surface water, but then also the social parameters such as population density, which is very consistent with impervious surface, and then income, what we get is a pretty accurate representation of urban flooding within a single community. And that's important because urban flooding is not necessarily related to rivers or streams or surface water or storm surge. It's inside cities, and it's because the storm systems get overloaded because there's no infiltration. So whenever you do have a rain event, all that storm water has to go into the system, and there's not enough space for it. And in areas that are lower income, they are experiencing more urban flooding. We have documentation of that, and then our model reflects that. And if you're lower income and you're experiencing flooding and you have damage to your home, you get less response from the city. You're paying fewer taxes anyway, and you can't bounce back as much as someone who has like a white collar, full-time, relatively easy to fund your life job. Because if you're working part-time and minimum wage and your home gets damaged, you can't fix it. And if you can't fix it, then you're going to get sick. And if you get sick, then you can't get to work. And then your kids get sick, and it's this whole perpetual cycle. So we want to highlight two cities that we're working with that these are some of the major issues that need to be fixed. It's a relatively straightforward fix if you have the data to make those decisions, because if you improve all of the communities across a city, then you're enhancing the economic vitality of that area as a whole.
Well, there's
part of it.
there's just a lot of interesting work going on with this information, like be it urban forests and area income inequality, and you can just sort of map out like with these areas. And so bringing stormwater into that conversation, really giving a lot of people evidence of like, okay, it's all these different multifaceted to hopefully maybe really start seriously addressing these things.
It's so cool to see how everything's connected. Who knew that stormwater would be so informative?
I used to deal a lot with stormwater, so I appreciate what you're doing. All right, so as we wrap this up, if people want to learn more, I know going to the website and such, but maybe going to a particular area, especially about the Terrapin, that there's ways that on the website that sort of really explain what the software is doing. What can you recommend for people to look at?
Certainly. So we have obviously the products tab, and then we have a series of case studies available. And within the next few weeks, we'll have Surfer available as well. We will have a free version that allows you to run your community and see what that looks like. And then obviously the paid version goes into a much greater detail and data analysis.
Okay, fantastic. Erin, it's always such a treat chatting with you. I'm hoping that we'll have that conversation of digging in maybe to the Surfer product, something. We'll do that. But thank you so much. And I encourage everyone to go check out their website. We'll have it on the show notes for this show. But Erin, I hope you have a great day. And I'm going to bring you to Just Chatting, but we'll talk to you soon.
Excellent, Doug. Thank you so much.
All right, folks, we're going to see you in Just Chatting.